Hello everybody, I hope you are all doing well. Today we are going to learn something related to multivariable decoupler controller design. Okay, so this idea is in fact is something a new idea for you all, I think. So let us take some examples and try to understand how to design a decoupler controller design. Okay, so let us take our a very well known example which you already been quite familiar with. Let us imagine we have a two tank interacting system with a single input and single output variable. So if you look at this two tank systems, clearly you can see by manipulating this M1 variable you are in a position to control this H2 variable. So every one of you, those who are watching this lecture, secondary and IB section students, in fact you'll be knowing very clearly that we can relate this H2 with this M1 variable, that is the input flow rate for M1 for the first tank, can be related through a transfer function something like this, R2 divided by tau square s square plus 2 zeta tau s plus 1. Okay, so I hope you will be quite comfortable in understanding this particular slide. Now let us make it little more complicated. I don't want a single input single output system. Can I make it a multi-input multi-output system? That's a question before you right now. So if I would like to convert this system into a multi-input multi-output system, what do? I'll be using a diagram something like this. Now look at the same system now got converted into a multi-input multi-output system. Instead of me controlling only the level in the tank 2, that is H2, I am also interested in controlling the level in the tank 1 also. Okay, now I have got two controlled variables, one is H1, another one is H2. Along with that, I would like to have one more manipulated variable. For example, in the previous case we controlled this H2 using this M1. Now what I am going to do, I am interested in controlling both H2 and H1. Along with that, I have one more manipulated variable, that is M2, the flow rate to this tank 2. Now if I would like to represent this two input two output system with the help of a block diagram, I'll be using something like this. But the key point that you have to understand here is, if M1 is used to control H1, that is M1 is used to control H1, I will be having only one transfer function. Okay, G11, that's the relation between H1 and M1. And at the same manner I can also relate it. If I want to control only H2, I have the variable M2, then this M2 and H2 are related by only G2. Okay, is it clear? Now I have only two transfer functions, G11, G22. But the key point that you have to understand here is the question. It is more like a question that you have to think here. If I vary M1, whether only H1 is going to vary? No. The M1, if I am going to vary, H1 is definitely vary, sir, but at the same time H2 will also vary. Is it right? So you have to think like that. Now in the same manner, if I am going to vary M2, is it going to have an effect over only H2? No, it will also have an impact over H1 also. So we need to capture that dynamics also in terms of two other transfer functions. So if I vary M2, it will have a say over H1. Likewise, if I vary M1, it will have a say over H2. So you have to understand this interactions between variables. So this kind of a system I call it as multi-input multi-output system. Okay, so this is where we stand. Now let us move ahead.